Thank you so much for the kind introduction. It's a pleasure to be with you all today. I want to talk to you a little bit about verifiable credentials and the innovation that this represents for document verification via the World Wide Web. So I've prepared a brief presentation that I will walk you through, and then I'll show a quick demo of an early version of a verifiable credential representing a Apostille certificate that we issued as part of the proof of concept we conducted with the Texas Secretary of State. So I'm going to share my screen. Okay. And all right. So first thing I'm going to talk about is the Bitcoin Ion network, and then I will move to the verifiable credentials standard, and then we can wrap up the presentation with a short demo. So what is the Bitcoin Ion network? First, let's take a step back and talk about decentralized digital identity in general. This is not just a technology buzzword. It promises a complete restructuring of the currently centralized physical and digital identity ecosystem into a decentralized and democratized architecture. So this is from a Forrester report from last year. The momentum behind decentralized identity has been building for quite some time. And the standard I'm going to talk about today is one that was developed by Microsoft to run on the Bitcoin network. So ION stands for Identity Overlay Network. It is a public permissionless decentralized DID overlay network that runs on Bitcoin and leverages a deterministic DPKI protocol called Sidetree. This enables the scaling of tens of thousands of DID and PKI operations per second on the Bitcoin blockchain. Best of all, it does not require any additional consensus schemes, validator lists, or special protocol tokens. So there's no additional cryptocurrency tokens associated with this. This is literally a new protocol that operates as a layer 2 protocol on top of Bitcoin. So, this is just a diagram of how this really works. You can think of layer 1 as the Bitcoin blockchain itself, which is a time chain that batches together transactions, cryptographically links each batch to another in a append-only data structure. That blockchain serves as a source of truth for the digital identity operations, which happen at layer 2 using the ION network. So in the same way that computers can run nodes of the Bitcoin blockchain, they can also run nodes of ION. It is used to anchor PKI operations. So what they do is they aggregate PKI operations into batches, embed those batch hashes in blockchain transactions, and then store the source data in a content addressable storage layer, both locally and over a peer network. So what this means is that you can basically create an unlimited number of decentralized identifiers. This is a globally scalable system at very low cost, and manage those decentralized identifiers in a very efficient manner. So, the DID standard was developed primarily to address the problem of human digital identity, but the reality is that in a digital world, we are moving toward the identity of all things. So it's not only humans that are going to have these decentralized identifiers, but any object, anything connected through the Internet of Things will need to be addressable using unique decentralized identifiers, each of which has its own PKI lineage. So, the upshot of this is that DIDs provide an identity you own and take with you anywhere. The DID standard itself is under development by the W3C, the World Wide Web Consortium that is the custodian for standards for the World Wide Web. Bitcoin is just one example of a blockchain that can anchor DIDs. Most blockchains, you can anchor DIDs to most different types of blockchains. The standards community is currently coalescing around, what a universal resolver might look like that could resolve DIDs anchored to any chain. But for now, there are separate DID methods for pretty much every chain. So if you think of decentralized identifiers as a way of managing unique identifiers for, say, data subjects, whether they are humans or machine or some other, verifiable credentials are ways of making attestations or claims about those entities. So we developed verifiable credentials because we needed a better way of validating claims on the World Wide Web. So, today we have digital signatures technology, we have other forms of verification, but they still left a lot to be desired as far as both security and certainty of the claim is concerned. So a verifiable credential is a tamper-evident digital credential with authorship that can be cryptographically verified. So you can actually trace the author of the credential cryptographically. Verifiable credentials is a technical standard also curated by the W3C for expressing credentials on the web in a way that is cryptographically secure, privacy respecting, and machine verifiable. And that's really the key here, is that verifiable credentials, once they are issued by a human authority or agency, do not need to be re-verified or reissued by human authorities every single time. So machines can basically take it from there and continue to verify the credential indefinitely. So the blockchain, in the verifiable credential standard, the blockchain functions as the verifiable data registry. It's important to note that verifiable credentials don't have to use a blockchain, don't have to be anchored to a blockchain. However, a blockchain does represent a highly secure, tamper-proof data structure that works very well for validating credentials. So, the issuing institution digitally signs these attestations or claims, packages them, and gives them to the credential holder. The issuer writes the credential to a blockchain or another verifiable data registry and issues the credential to the holder. The holder can now manage their own credentials directly. So whether that is through a mobile application or a web wallet, they can now store them and share them at will. They can also use them to create various presentations of proof for verifiers. So, if a government needs to see, let's say your birth certificate and high school diploma and an electricity bill, all of these could be issued as verifiable credentials and then packaged together as a presentation that is also verifiable and then submitted to the verifying entity. And that verifier can then instantly verify those attestations mechanically. So by tracing the cryptographic authorship of those credentials. So I thought it would be useful to just really clarify what improvement this represents over digitally signed PDFs. PDFs are extraordinarily versatile documents and file formats, so there's a lot they can do. There are some things, though, that they can't do as well. So, for example, it's not possible for the recipient of a digitally signed PDF to control their cryptographic keys that are associated with a countersignature on that PDF. So if I want to prove, for example, that my Harvard diploma was issued to me and all I have is a digitally signed PDF, the only thing that I can prove is that Harvard issued this diploma. I cannot prove cryptographically that I am the recipient of that diploma, whereas with verifiable credentials, I can. I also, with verifiable credentials, have more flexibility around the data schemas that I can embed in my data and display layers. The revocation is also far more sophisticated. So a digitally signed PDF, that digital signature can be revoked by the signing authority. It can also be expired by the signing authority, but if the issuing institution is not the signing authority, say Harvard is using a third-party vendor to sign that diploma, then Harvard cannot actually revoke that diploma. They would have to contact that vendor, and the vendor would have to revoke it on their behalf. Now, if the vendor is no longer around, has gone out of business, or no longer supports this product line, that digital signature, in effect, is never going to be revocable. Whereas with a verifiable credential, the issuer has more direct power over revoking and expiring those credentials directly. So it really puts a lot more control back in the hands of the issuing institution over the validity of their credentials. And then finally, the vendor independent verification portion is perhaps the most important difference here. Most digital signatures and digitally signed PDFs have to be verified using the software that was used to sign them. So if I have issued a digitally signed PDF using Adobe or DocuSign or a government service, it would also have to be verified using Adobe or DocuSign or a government service. Whereas the W3C verifiable credentials standard enables vendor independent verification, meaning completely open, free, and instant verification by anyone, anywhere in the world, without relying on any proprietary vendor services. So that is really what represents the greatest breakthrough in usability, because now that means I can receive and hold, for example, my Apostille certificate. I can share that with anyone, anywhere in the world. They can instantly verify it with the click of a button without having to go to, a portal, log in with a username and password, search for my Apostille, or pay a fee to a third-party service to verify that document. I can simply click a button or scan a QR code to validate it. So that's the short presentation. Before I jump into the demo, are there any questions so far? Okay, I see no questions. So I'm going to open a browser window here. And today I'm going to show you an example of an early version of verifiable credentials called block certs. This is a version that my company Hyland developed with MIT and open sourced in 2016. So you can actually find all of the open source repositories and libraries here to build your own solutions for issuing and verifying block certs using nothing more than a web browser. So this here is a universal verifier. And what that means is that it uses the open standard to validate any document that has been issued as a block cert by any institution anywhere in the world. So again, there's no need to go to a special portal, username and password. You don't have to look up the certificate, using personally identifiable information. All you have to do is really drag and drop a credential directly into the verifier. So I'm going to do this with the electronic Apostille certificate that we issued for the Texas Secretary of State. So as you'll notice, this has gone through a multi-stage validation. This has actually checked the blockchain to ensure that this e-Apostille certificate was not tampered with in any way. So nobody has gone in and changed any data here. It is exactly as it was when it was first issued. It then checks whether or not the certificate has been revoked by the Secretary of State. It has not. It confirms that the digital signature has integrity, meaning that nobody here is trying to spoof or fraudulently represent themselves as the Secretary of State. And it checks the expiration date on the certificate to ensure that it has not expired. So once all of these checks are passed, this shows up as a verified certificate. Now I can actually view the transaction on the blockchain itself if I click this link. So this will take me to the Bitcoin blockchain It tells me exactly which block it was appended to, the public key of the issuing institution, in this case, the Texas Secretary of State, is deposited on the blockchain. Now, keep in mind that when we switch to using DIDs for these identifiers, it will be a DID document that is anchored to chain using, for example, the ION network rather than a public key directly on the blockchain. But this is an early version, so I'm just using it as an example. You can also see that the date and time of the transaction, when it was anchored to chain, and how much Bitcoin it cost to anchor this transaction to the network. So this is the validation. And then here, when I click out of that, I can see the Apostille certificate itself. Now, this is just the certificate, but we would, of course, issue this with the underlying document appended to it. This was just a proof of concept, so we didn't do that here, but you can append PDFs to embed them within a block cert to have a multi-page certificate issued. So this is the front of the certificate using the standard Secretary of State format. We can see the issuer's public key here, their unique identifier, the transaction ID of the Bitcoin transaction. And then here I can view the metadata to see the back of the certificate. And this is all fully customizable by the Secretary of State. So they can add, this certification, the issuing entity name, the issued date, certificate number, as much metadata as they want to include here on this back of the certificate. And all of this data is present in that JSON file that I just uploaded here. So we call the block cert a self-attesting or self-verifying credential, meaning that you do not need anything other than that JSON file to validate it, because verification is free and open source using the blockcerts.org universal verifier. So this is really a breakthrough in digital document verification, and we look forward to continuing to build out the solution. And I'll pause there and open up the floor for questions. We have several questions here in the chat, so I'll go ahead and get started. Angel Alberto Santana asks, I would like to know if this validation is possible for all states or not. Yes, I mean, the technology is ready. So any state that wishes to adopt the solution, I mean, you can contact me. I can help direct you to understand the next steps to implement a solution like this, but it's really quite straightforward. The next question is from Mayela Chelis. Thanks. Are you saying that with blockchain technology, the current e-app e-registers implemented by some states would be outdated and unnecessary? So there are a couple dimensions here. The e-register is often used to identify the issuing institution. And this would still be required even with decentralized identifiers, because you need to know which institution owns which decentralized identifiers. So you can create a registry that says, for example, this decentralized identifier belongs to the Republic of Malta. And everybody knows that, any apostille issued with that decentralized identifier was issued by Malta. However, you don't need the register for the apostille certificate itself. The certificate will self-verify using these open standards. From Robert Bond, does the e-apostille sit within a notarized document, or is it in effect on top of it? So the blockchain verifiable credential standard is in effect a replacement for other digital notarization technologies. So instead of notarizing a document digitally using, a digital signature on a PDF, you would simply issue the verifiable credential as a digitally signed JSON file, and that is your notarization, because you're digitally signing that and anchoring it to a blockchain. or associating with it with a DID that is anchored to a blockchain. So it's a more advanced form of digital notarization. That said, you can append a previously notarized document inside a verifiable credential. So if I submit a notarized birth certificate for the electronic apostille, then the issuing authority would create a certificate, append that notarized PDF to the certificate digitally, and then issue that entire package as a signed JSON file that is the notarized verifiable credential. All right, I think that was all of our questions today.